Okay. I'm going to try this. I've never tried it before, but I always kind of wanted to. So I took a look at the problems and just a couple of little notes. It says to use 45, 45, 90, and 30, 60, 90 triangles. So I did just kind of a general idea of what those are. If the hypotenuse is 1 in a 45, 45, 90 triangle, each side would be root 2 over 2. And you can get that using the Pythagorean theorem. And then in a 30, 60, 90 triangle, the side opposite the 30-degree angle is half the hypotenuse, and the side opposite the 60-degree angle is root 3 over 2 times the length of the hypotenuse. And so that can come in handy. As a general strategy, locate the angle on the unit circle, just because the unit circle is a really good frame of reference for finding the angles. Determine the type of triangle you're looking at, so which one of these it is. And I did notice that some of them won't form triangles, which I thought was a little weird. And then use SOHCAHTOA to figure out the answer. And then another thing that will come in handy, since at least one of them that I looked at, the number 9 won't form a triangle, is on the unit circle. If you have any angle, the x-coordinate of the point on the circle is cosine of the angle, and the y-coordinate is the sine of the angle. And then you can determine the sine, S-I-G-N, of the x or y coordinate by what quadrant it's in. So like x is positive in these two quadrants and negative over here. Your y coordinates are positive here but negative here. And so that will come in handy as well. So just to demonstrate it, I'm bringing the marker cap out of my mouth. So we have negative 135 degrees. So I'm gonna put my unit circle on here, and that's a terrible circle, but. And we start here, and because it's negative, we're sweeping clockwise. So we go 90, and then this would be 180, and 135 would actually be halfway between. And so that's where our angle would be. And then you always form your triangle with the x-axis. And so there's our triangle. Now, if this is negative 135 degrees, and you know that a straight line is 180, that would make that a 45-degree angle. And so we're dealing with a 45, 45, 90 triangle with a hypotenuse of 1. We want to know the cosine of the angle. And so what we do is we find the cosine of 45 degrees, which would be adjacent over hypotenuse, which in this case would be root 2 over 2 over 1, or simply root 2 over 2. And then because of the quadrant it's in, your x-coordinate is going to be negative because we're over here on the coordinate plane. And so that makes your answer negative root 2 over 2. And then I would double check that on a calculator just to be sure, just for that peace of mind. You do have to bump your calculator back and forth in mode. So mine is in degree mode, and then you can just do cosine of negative 135 degrees and then compare that with negative root 2 over 2, and they match. And so you can have some confidence that you've done the problem right. Next one is in radians, which nobody really appreciates because they're just not as comfortable to work with. But the strategy would be the same. This time we're going negative pi over 3. And you know that this would be negative pi because going halfway around would be pi. And so we want to go about 1/3 of the way, which would put us right about there. That would be an angle of pi over 3. And of course, that would be our triangle. And what probably your teacher at some point said you should know is that pi over 3 radians is 60 degrees. So we are looking at a 30, 60, 90. And we want to know the sine of this angle. So that would be opposite over hypotenuse. So opposite would be root 3 over 2 over 1. So it would be root 3 over 2. And then because of the quadrant we're in, we know our y coordinates are going to be negative, and so it's negative root 3 over 2. And again, you can check that on your calculator. You do have to change the mode, which is annoying, but you do have to do it. And then sine negative, sorry if you can't see what I'm doing. Oops. And compare that with negative root 3 over 2, and you can see that you get the same answer, and so we know that we've done it correctly. I skipped a page. Here we go. This one I thought was really telling because it's not going to form a triangle. And you do need to remember that cosecant is 1 over sine. And so what we need to find is sine of negative 180 degrees because you can't really find cosecant. At least you can't check it on your calculator. So once again, we're sweeping negative. Only here, when you go negative 180 degrees, you end up on the circle itself. You end up on the x-axis, and so there's no triangle. And so that's where this little factoid comes in handy, where you know the x-coordinate is cosine and the y-coordinate is sine, and we know we're looking for sine. This point is negative 1, 0. So the sine of negative 180 degrees is 0, and that is, undefined. And then the last one, tangent, just kind of get a variety. 30 degrees, we're back in degrees, yay. And so this would be our triangle. So we have a 30, 60, 90, and we want to know tangent, which of course is opposite over adjacent. Opposite over adjacent. So from a 30-degree angle, that would be 1/2 over root 3 over 2. And the worst part of this is actually the manipulating the radicals and the fractions. So dividing by a fraction is the same as multiplying by a reciprocal. So we end up with 1 over root 3, but of course we can't leave a radical in the denominator. So we multiply by root 3 over root 3, and we get square root of 3 over 3. And then again, just for peace of mind, I have to go back into degrees. So tangent of 30 is that mess of stuff. And then I hope when I do root 3 over 3 that I get the same thing, and I do, and so I know that I've done it right. So I hope that helps. I know this video is kind of long, but it went through several of the problems that you had. Send me a text message if you have any questions. Awesome.